Okay, we're going to process a flight. We've done a flight with the Trinity F90 Plus, and in doing so we have 3 pieces of data, 4 actually. The first thing we have is the photos. The photos come from the SD card of the camera after the flight. We have the fly.bin file. The fly.bin file was downloaded from the plane after the flight. We have an O file. It's a Rhinix observation file from the base station. In this particular case, we are running a Trimble base station, but the same file can come from the little puck that comes with the drone, or it can come from a Qbase site, but you need a base station file. So the base station file gets processed against the bin file to post-process for high precision. The other file in here that we have is just some control points. These are the panels, the location of the panels. And this is actually not needed in Quantum, but will be used when we process the data. So we go to Tools. We say Geotag Images after flight. It says Select Fly Log. Now, if you have the plane connected to the USB port, you will actually see the files on the plane, and you can download them right here. This is supposing you've already downloaded the file, and we're going to select that fly log. And we open the fly log, and it takes a second to load. And then once it loads, it's looking for the photos. So let's select the image directory. One of the reasons I like to create a folder and put all my data into one folder for each flight is just helps keep everything organized. On this flight we had 438 photos. We had 438 log events. That's very good. It's asking for select output directory. By default, it'll go to wherever the log file is, and it'll create a geolog folder. And once it geologs the photos, they'll be in there. Now, see all these little red switches? You're going to choose what you want. So we want high precision. We want geotagging. If you're using Propeller, hopefully in the near future, the Propeller file will be something you want. They're still working on that right now. I'm going to hit the check for precise positioning. And when you click on that, right away it pops up, and it prompts you for a remote reference station like a Qbase site. And if I trusted this Qbase site, I could click on it and use it. But I don't. So I'm going to go to a local reference file, which is my local base. And from my local base that I set up on site, I downloaded the Rhinix file. And I'm going to choose the Rhinix file to process against. And then down here, it defaults to auto detect reference position. If we were to auto detect reference position, it would take the mean average from this base file and assume that's the base location. If you're in any kind of surveyed control network, you need to not use the auto detect, but rather use the stored reference position, meaning the coordinate for the actual control point. So how do you get this? Well, this is probably one of the more complex little things to deal with when you're running the software. You need to supply the coordinate for the base point in global coordinates. That means latitude, longitude, and it's actually ellipsoidal height in altitude. So how do you do that? Well, what I do is I bring in Business Center, and what I do is I load a projection. So right here you can see it's calibrated. To load a projection, easiest way is to drag the DC file in. You can also go to the construction data menu, go to job sites, and load a site. Once the site's loaded, down here in the corner, the bottom, you'll see calibrated, meaning it's calibrated, which means that the northing and the easting actually have a corresponding latitude and longitude and global coordinates. And then so if I query the control point, I can literally click, right click, copy, and then go to quantum and paste it in. And so I'll just do that. A couple of things: the latitude and longitude need to be in decimal degrees, and they need to have a minimum of 7 decimal places. So in Business Center, if you go up to the little project settings, you can go down to coordinate, and under units, go to coordinate and change the decimal place. I just kick it out to 9. And then down here under latitude, longitude, if you click and scroll down, I change it to decimal degrees. And then once I do that, when I query the point, I have the data just the way I want. The one thing is I need to convert the feet to meters. Other than that, it's good to go. And then I paste that in right here. And one thing you can do if you're going to use the point again is store it, so the next time you don't have to type this stuff in. So we have latitude, longitude, altitude, and ellipsoid height. And then over here we have our HI. So if we're using a Trimble receiver, we need to take the control point and plus the HI, like if it's on a tripod, it might be 5 foot in the air, and then take the measurement from bottom of antenna to phase center, and what you want is phase center. So you need to do the HI from the measured survey point to the phase center of the receiver. So like on a Trimble SPS 985 or 986, it's 0.47 from bottom of antenna to phase center. So I add 0.47 to my HI, and then I convert that to meters, and that's what I put in there. So I've entered in the coordinates here. When you cut and paste the coordinates from Business Center, north is positive, westing is negative. Convert the altitude to meters, put the HI in. The HI is a 2 meter pole with the offset 0.143 to the phase center. And so that's all set. So we've got our control point coordinate for our Rhinix file, and we need to geotag. And if you're doing a propeller file, you can do that and hit start, and it will process. So the outcome, it generates this fly file, and in that folder you'll see a geotagged folder, and you'll see all your photos. You go into your photos, you go to properties, details, scroll down, you'll see your coordinate there, and these have been processed and geotagged. So if you go into propeller and you're uploading a new data set and you drag the folder that contains those images, what you should see is your images come in something like this, and all yellow. Then you go down and you connect. Photos have high accuracy geotags. You will get ISO errors in the filter from propeller, especially with a fixed wing. Generally, it's not a problem. and you hit next, and off you go. Give it a name and add your panels. If you're flying the Quantum, you should probably have like 5 panels, 3 minimum 3, but 5's better because you're covering large areas. And the data's already been post-processed, unlike the P4. You upload it and you should be in business.